Hey guys, good morning all. Just give me a yes in the chat if you guys can hear me and see the sublime text. Quickly give me a yes in the chat if everybody can hear me loud and clear and you guys can see the sublime text. All of you can? Cool. I see some of new people have joined. That's what I was seeing in one of the messages as well. Just give me a moment. I'll answer the queries. Let me go one by one. 7 class done already. Can just okay to continue from today. Considering number of topics covered, we can go through recordings or shall we wait for new batch? Okay. So those people who are joining for the first time, as of now, we are pretty much at the end of the course. End of the course in the sense we already had the 7 classes done for this batch. This is the eighth class or the eighth class which is going for this batch for low level design. Just a brief about what we have covered so far. We have covered in terms of low level design, requirement gathering, laying down the use cases, UML and class diagrams, where we talked about class diagram, activity diagram, use case diagram, and sequence diagram, object oriented versus object oriented design. We talked about classes, objects, NVT technique, creating a case study. We talked about different class relations, including composition, aggregation, inheritance, association, and abstraction and encapsulation we have done. We also have done the design pattern, solid, keep it simple and short and dry. And currently we are doing finishing our last or second last design pattern, which is builder design pattern. And then we have 3 classes reserved for case studies. So if you have the access to recording, yes, please go through it ahead. I would not recommend whether you have to go through a new batch or something. That's something your personal decision. But this is pretty much at the end of the session or end of the batch that I can definitely say. If you feel like watching recording would give you the kind of knowledge that you need, feel free to go ahead with it. If you feel like joining a new batch is a better idea, I'll leave the decision up to you. But as of now, we are just left with 3 or 4 classes before wrapping up. Last 3 classes deserve only for case studies. So mostly by today or maybe another class, we'll be finishing up all the theory. Then we'll directly go to the case studies. This is currently where we are. Okay. All right. I hope that answers your question. In case there any follow-up, let me know. Now coming back to the last class that we had. Last class we had was on 9th of Feb. I'll quickly revise what you discussed till then, and then we'll continue with today's session. So in the last class, we were completing about the design pattern. So we go ahead with the number 4 part, which is the code of the singleton design pattern. Factory code, we have already talked about factory design pattern. We have gone through the code. So in general, when I compare design pattern, I talked about problem and what is the solution to that problem, because all design patterns are solution to one or the other problem. So we talked about problem, we talked about solution, we talked about real life example, then we go to code and then we compare pros and cons. So in the code part, we first covered the eager loading and lazy loading part of singleton. We also talked about thread safety, how you have to make thread safe for singleton, and so on and so forth. We got the output accordingly. Then for number 5, we covered the eager loading, lazy loading earlier. Eager loading means you're creating an instance at the compile time or load time. Means the instance will already be instantiated as soon as your application is up. Lazy loading means you're creating the instance at runtime, means your instance is instantiated only when application module will call for it. We talked about thread safety for a bit, and finally we talked about the usage. So singleton design pattern is very commonly used in terms of logging, caching, thread pools, config classes, enterprise Java beans, message-driven beans, and DB calls or DAO objects in general. And then we finally talked about the summary. The summary was it's a neat way to handle access for shared resources. It's easier to implement. It guarantees one instance and solves a well-defined problem wherever you need one common instance to be shared across all application modules. And thread safety can be ensured as well. Okay. We talked about in singleton, we should not pass the parameter, otherwise it will behave as a factory design pattern. And then we move to the next design pattern, which we are continuing now. We have not covered the code part. That will be covering for today. And that is what we call as builder design pattern. Now, in terms of builder design pattern, 6 things to talk about. Number 1, what kind of problem builder design pattern solves? Why do we need to know about it? Second, understanding with the real life example. Third, in terms of implementation. Fourth, usability. Fifth, code walkthrough. And sixth, summary, pros and cons. Okay. So going with number 1, problem solved. What kind of problems? Yes, all the codes are in Java. Number 1, what kind of problems is solved by the builder design pattern? Let's start with number 1 first. So the kind of problem that builder design pattern does is creating a complex object. Okay, what is complex object? We'll go back in a bit, we'll understand that. But the main problem it solves is creating a complex object. It makes the effective use of telescopic constructor. What a telescopic constructor we are going to learn in the code with the example I'm going to share today. This helps with immutable classes, something which cannot be mutated further, and this is less need for exposing setter to the client classes. Both getter and setter technically to the client classes. Now, the one thing which I mentioned, or the most important use case I mentioned for builder design pattern is creating a complex object. So what exactly is a complex object? Let's understand. Builder is a creation and design pattern that lets you construct the complex objects. This allows to produce different combinations or variations of object using the same constructor code. Example, if let's say in my object there are 10 fields, right? So in my class they are defined as 10 fields. If I want to create one object where I need only two fields out of this 10, right? Or if I want another object which I need only eight fields out of those 10, that is something which is easily possible by built design pattern as compared to a plain old Java object. What exactly is a complex object? Complex object means a step-by-step instantiation of many fields and nested objects. Such initialization would be difficult, so we have to do with a lot of constructors. That's what we call constructor overloading. Take an example, what is complex object? Complex object basically which contains nested objects, right? And multiple fields inside it. So if we talk about this example, this payment is an object. I'm pretty sure all of you would have dealt with this in your production ready code. You have a structure called payment. Now payment has three fields. All these three fields have substructures also. So there's a credit card, there's a debit card, and there's a UPI. So credit card itself is an object, debit card itself will be an object, UPI will be an object too, right? This is what we call as nested object or complex object. So my payment is a complex object. The purpose of using builder design pattern is I will make the instantiation easy for my payment class, which is quite a complex object. Then you move to real life example. Let's talk about it. The example number one is if I have to create a house, let's try to understand a complex object house and what possibilities we are talking about here. If I have to make a house, first thing there would be something called essential, something called the amenities. Essential means you cannot bring that object without that, and amenities mean those are optional on top of it. So if I have to build a house, I would need four walls, I would need door, I would need window, I would need land, I would need roof. This is definitely I need. This is what my essential is. Amenities is something on the top, which is the optional. So I can have an AC, I can have a washing machine, heaters, patios, garage, multiple floors, garden, etc. Pool. Now, there are three ways how we can build it. And let's see what are the issues with each of the way. Obviously, the two ways, and third one is the design pattern. First is I want to implement this by inheritance. This is the problem statement. I want to make a house object. There are certain essential part, there are certain optional part, and I want to create multiple combinations of that. So one of the house may have the washing machine and do not have the heater. One of the house may have garage and do not have the multiple floors. I want to create whatever possible combinations I can think of. I want to implement this in three ways. Or basically what we can think is we can think in three ways. One is by inheritance. Second, by using multiple constructor with multiple arguments or parameters. And third, using builder design pattern. Okay, let's go one by one. Starting with number one, which is inheritance. If I have to implement this by inheritance, how would I go about by implementing by inheritance? The first thing that I can think is I can give the parent class as the house, right? And the properties will remain same, which I'm calling as essential. So call it as four walls, door, window, land, and roof. Those things will remain same. Then I can create specific child classes based upon the combination I want in the house, right? Combination in the sense, whatever combination that you can make out of it. You want AC, you don't want AC, you want patio, you don't want patio, so on and so forth, right? Anyways, all of them will contain these four basic properties, which is coming from the parent class. What is issue with such kind of implementation? The issue with such kind of implementation is in each of the requirement, I would need a separate child class. So let's say if I'm making 200 combinations of houses, I would have 200 child classes to handle in my code, which is not a good way. This part clear to all? Everybody can visualize this. If I try to implement this via inheritance, this will lead to the problem of creating multiple child classes. Too many child classes as per combination. Everybody can relate to this, visualize this. Okay. Second way we talked about is multiple constructor or constructor with multiple arguments or parameters. So what is the second approach we're talking about? Rather than using this inheritance and having multiple child classes, what we're going to do is we're going to create one constructor and we'll pass all the variables in one constructor. Has windows, has doors, rooms, garage, swimming pool, garden, etc. etc. Now, for object one, which let's say new house, I can pass the value true false whether I need that combination or not. So considering let's say there are 10 parameters, there would be 10 different possibilities or 10 different parameters passed in the constructor now. So this will be object one and then similarly can be object two with the value true, false, etc. etc. Again, there's an issue with this. What is the issue? This will become ugly calls to the constructor. Why? Because I'll be using all the variables as part of one constructor. That is what I'm referring to as ugly call. There are too many permutations I have to pass. I need to maintain the order of increments also. So let's say there are 20 parameters. If out of the 20 parameters you miss one of them, then you miss one value, then constructor is not correct. So I have to maintain the order of arguments because there can be chances of mistake. There's passing information which might not be required. For example, if I want a house which has just the garage, I don't need the information whether it has swimming pool, has a garden, etc. etc. So ideally it is hiding the properties or it is telling me the properties which should have been hidden because think it from a client perspective, a client is just interested in having a garage. Should we expose that it can have a pool or garden and other functionalities also? The answer is no. So it is passing the information which is technically not required. Okay. A house created with pool does not need to know that a house can also be created with a garden. Same example which I just said. So this is the problem with these two approaches, using with inheritance or using with multiple constructor. Let's see how does builder design pattern helps us do that. Okay. Builder design pattern is the correct solution here. So first thing first, if you have to check in your code base if you are using builder design pattern or not. Similarly, I told you about the factory also. Search with the keyword factory, that will tell you. And I told you the identification of factory in singleton. If you have to check whether a builder design pattern is used in your company code base, just go to the repository, whichever repository you're working with. Search for this configuration @builder. Wherever you see the word @builder, it's a Lombok configuration also, by the way, and or just search .builder and this function. Whenever you see this in your code base, be clear that it's implemented via builder design pattern. Okay. So it usually goes like this, whatever class name .builder with variable a, value b, etc, etc, whatever that is. Okay. So finding by builder would be the best way to find out whether you're using your builder design pattern in the code base or not. Now coming to example. Code example is if I do a simple plain old Java object, right? If I'm creating a plain old Java object, let's try to understand that, and we'll talk about this problem statement again in today's session. If I, let's say, I have a class Devang, it contains two variables, string name and location. So I pass a constructor name and location. I set the value this dot name, this dot location. So I put this value and I'll be able to create an object out of it. Simple. But if I do the same thing with a builder design pattern, what is the difference? With builder design pattern, I can again have the string name and location. Nothing will change on the functionality of a class. The way that I'm creating an object, I'm build with the name, build with the location, and dot build. Now, what's the difference between this implementation and this implementation? This is the important part to talk about. How is this code where we are creating a constructor here or creating an object via constructor here is different from the builder part? Let's try to understand that. There is an issue which is being solved by builder design pattern here. What is that issue? Imagine I want to create a combination of an object with only the name and no location. What do you mean by that? I want to have the name, but I don't want to give the location here. If I go by this method, the constructor method, if I try to create new Devang Dev and I don't pass anything here, will my code work? Will my code work? No, my code will not work. I need to pass a location here. Constructor overloading you can do. In that case, you can just pass that and you can make through that. That is one way. I'm not denying that. But in general, if you talk about constructor containing all the fields, this code will not work. But if I do this with builder design pattern, I can do it. This part is optional. This part is optional. I can add the values, only the values that I need to add, right? So if I want to create an object which only contains name or only contains location or contains both name and location, I can include that. So this is which is achievable in the builder design pattern. Okay. That was one example. Then we'll talk about second example. Then we'll go to telescopic constructors. We'll go to code walkthrough. Okay. We talked about second example, which is real life example of a pizza. So in pizza, what do you have is the two things are essential, which is one is size and one is base. So size can be either small, medium, large. Base can be either thin crust or thick crust. Option on top of it, you can have the toppings, you can have the sauces, etc., etc. So if I'm trying to create a class pizza, let's talk about it. I have created multiple constructors here. First pizza, which will contain only size and base. Second, which contains size, base, and cheese. Third, which will contain size, base, and pepperoni. And let's say size, base, cheese, and pepperoni. This is what you call as constructor overloading. You're creating multiple constructor based upon different parameters or return types. Now, first use case is if I just want a margherita pizza. So margherita pizza, if I have to create a margherita pizza or if I have to create margherita and cheese pizza, I would be able to create another constructor here. Because of now, there is no constructor which is able to create a margherita pizza, right? And for type 2, I need to create another cheese as well as a margherita pizza. So every new requirement, I will need to create a new constructor all the time. This is the problem with this. Okay. So if I try to implement it with a simple plain old Java object, I would not be able to, because that's the kind of problem I'll be suffering with. Okay. Now moving to next in terms of code walkthrough, that's what we'll continue with today. What we are going to do as part of our code walkthrough or the code for builder design pattern, the case study that I have particularly chosen, is we are going to build a URL builder. Now, what is URL builder? We are going to create URL object provided with some parameters, right? If you know about URL, this is how the structure of URL looks like. So there is a protocol, there is a host name, there is a port, there is a path parameter, there is a query parameter. Now, out of this, there are some essential values and some optional values. What are essential values? What are optional values? Let's talk about it. So if I talk about essential values, My protocol and my host name, these are my essential values. You cannot create a URL without having a protocol or host name. So these are your typical essential values. On top of that, you have some optional values, which includes your port, your path parameter, and query parameter. So this port is optional, this path parameter is optional, this query parameter is optional too. Okay. So if I talk about google.com, I just have the protocol and I just have the host name. I don't have any of this. Okay. So these are the only essential things I need. Now this becomes the kind of problem statements which we have been discussing. You have to create multiple combinations of an object. In that combination, there will be some essential values and there will be some optional values, right? So these are the essential values, these are the optional values. You have to create multiple objects which can include different combination. How would you make it, right? We talked about the problem we will find in terms of inheritance. We talked about the problem we'll find in terms of creating multiple constructors. Can build a design pattern help me solve this quickly? That's what we are discussing about here. Okay. So this is the problem statement. If I have to compare with the analogy that we discussed in terms of house, house also has something essential and optional. Same goes for URL. We have something essential and optional. Okay. So I'll take this guy. I'll start with number 5. That's what we are discussing, and we'll continue from there. Before I start with today's session, any doubt or anything we discussed so far, just let me know. Anything, any questions, anything which is not clear, let me know. If it is clear, just type clear in the chat. Come on, guys, be quick in the chat. Okay. All clear. Now let's come back to what we need to make. I'll take this guy. This is the URL I need to make. Yes, we'll finish this builder today. And we're already discussing builder. It's just that I'll finish with the code example. That's it. Okay. Cool. And if you're able to finish it, then we'll go to abstract factory. That's the next design pattern. Now coming back to this, number 1. I would like to implement this design or implement this way of creating a URL as an object, which is a complex object, with a simple plain or Java object. Okay. So out of that, I have 2 mandatory fields, protocol and hostname, and I have 3 optional fields, port, path parameter, and query parameter. So I want it without any design pattern with a plain Java code. Okay. Without any design pattern with a plain Java code. So if I have to implement this kind of a structure, 2 mandatory fields, 3 optional fields, without any design pattern, with a plain Java code, how would you do that? If I'm simply doing with a Pojo object, I will create a URL class. In that URL class, I will think of 5 parameters. I'll think of 5 getters and 5 setters. Yes or no? This is how probably you would have thought of the code. If you're simply using no design pattern, if you're just using a simple Java class. All agree with this? Yes or no? Come on, guys, quick in the chat. All agree with this? Okay. Let's go through the code which I'm talking about. I'll come back here. Let's go to the builder design pattern. Okay, why this design pattern is overwritten? Let me check real quick. Okay, I was looking in the wrong place. Anyways, let's come back to it. I'll quickly share my IntelliJ. Let me know once you guys are able to see it. Come back here. Cool. I'll close the .class files real quick so you guys can see the code here. Now what I want to do is I want to show you something. This is my URL. This is my builder. This is my telescope. I'll go one by one. Okay. But first I'll comment this guy. I don't want to show the builder design pattern code. And I'll uncomment this guy. What else we need? URL. We'll go through the code of URL once we run this code. First, let's run this code. Anyways, let's run this code. All right, we got the output, but before we go there, let's try to understand what we are doing here. See, let me zoom this a bit. I have included this, import the class, adjust by itself, do it by itself. Anyways, what I'm doing here is I'll refactor it later. I'm not interested in refactoring now. This is my driver class code. What exactly we're doing in driver class code? Public static void main. Understand what I'm doing here. I'm trying to create an object with URL class. So first thing, I create an object of URL, which is the URL class I'm talking about. I'm setting the protocol, I'm setting the host name, I'm setting the port, I'm setting the path parameter, I'm setting the query parameter. These five values I need. Then I'm printing get protocol, get host name, get port, path parameter, query parameter. So this is what you're getting in the output. When you print your final value, this is the object you're getting with URL class. So first you get the protocol, which is HTTPS. If you look at the output now, HTTPS, then you get the host name, which is my website. Then you get the port, which is 8080. Then you get the path parameter, which is homepage, and then you get the query parameter. This is completely without any design pattern. Simple, plain old Java object. How did we implement the code? Let's go through the code part. I simply created a public class URL. Let me zoom this a bit. I simply create a public class URL. What I have there is I have five values. One is a string protocol, one is a string host name, then there's a port, there's a path parameter, query parameter. I create a constructor here. In that constructor, what I'm doing, observe this code carefully. This is constructor overloading. So in one constructor, if I'm just passing the protocol, I just set the protocol and host name. Other constructor, I'm passing both protocol and host name. Third, I'm passing protocol, host name, and port. Fourth, I'm passing protocol, host name, string, port, and parameter. Fifth, I'm passing all the values. Then I have five getters and I have five setters on top of it. Look at this code. I'll take this code real quick, bring it back to Sublime Text. This is how the code will look like. You have five values. In that five values, you will have get parameters, five getters, five setters, so on and so forth. Okay. This is your implementation class. And I'll give the code for driver class also. In driver class, what you're doing? One moment, one moment. Driver class, this is what you're doing. Okay. I'll remove the package. You can keep the package whatever you want. I'm not interested in the package part or interested in the class implementation. Okay. Now look at this piece of code. I'll cancel this. I'll come back here. Constructor overloading, too much verbose. Correct. Coming back to this. No, this is not example of telescopic. I have not started with telescopic. Next part is telescopic. As of now, I'm just dealing with plain old Java object without using any telescopic constructor. We'll talk about what is telescopic constructor. What I've done here is, since there are five fields, which is protocol, hostname, port, path parameter, and query parameter. All I'm doing is, out of these five values, I need to initialize those five values, right? Some of them are mandatory, some of them are optional. So what I'm doing is, I'm creating multiple constructors, which is what you call as constructor overloading. One constructor with only protocol, then protocol plus host name, and various other combinations. So five different constructor I made for five different combinations. Then I have five getters, and five setters. So in the driver class, what I'm doing, I'm setting these values, right, based upon the constructor I've defined. I'm setting these values, and then I'm getting those values in the output. This part clear to all. If you have to implement without knowledge of any design pattern, this is probably how you would have implemented it. All agree with this? Someone just quick in the chat. This is most probably how you would have implemented if you don't know about any design pattern. Now tell me what is wrong with this code. What is something that you see as a problem in this code? I mean, your code is working, it's giving the output, but is it a good code? Will you call this as a good code or good implementation? Correct. The answer is it is not a good code, first of all. Just because it is working doesn't mean it's a good code. Number two, all possible constructor is overloaded here. Okay. So if I have to create a new field, let's say if I have to create a field number 6, I would need to create a constructor overloading for that as well, which is not good. This exploits the open close principle. Remember the solid principles we talked about? If a new field needs to be added, this will require another constructor overload, which technically defines the purpose of OCP, which is open close principle. Everyone agree with this? Come on, let's speak in the chat. Okay. So how do we solve such kind of problem statement? This was one way. If I have to implement using a plain old Java class or plain old Java object, this is probably how I would have done it. Let's see if there is any other way to do it. Then we'll talk about second solution. So open close principle, it should be open for extension and close for implementation, right? So if I got another field here, ideally I should not be creating a different constructor altogether because that constructor will be called into the client classes. That's why it is violating the open close principle. Now, this is definitely not a good solution. Just because we're able to implement it doesn't mean it's good. Let's talk about other solution. What can be other solutions? Number one, telescopic constructor. And number two, builder design pattern. Even telescopic constructor is also not a good approach. We'll talk about what is a telescopic constructor. That is definitely an implementation, definitely a optimization from this code, which is plain old Java code, but it is nowhere equivalent to builder design pattern. The correct solution to implement complex objects is always a builder design pattern. We'll see about it. First, let's understand what exactly is telescopic constructor. Then we'll go through the code of telescopic constructor. We'll try to see how it is working. Okay. First, let's understand what is telescopic constructor. Telescopic constructors does not completely solve the problem. This is the first most important part. So whenever you're using telescopic constructor, that does not mean it is solving the problem. It is not completely solving the problem. It is definitely an optimization. I'll give the due credit. It's an optimization than the plain Java code. And that optimization is we are reducing some lines of code. Not too many, some lines of code. That's all a telescopic constructor is doing. It's not solving the purpose, which is purpose of creating a complex object. That's not what it is doing. But definitely it is a bit optimization than plain Java code by reducing some lines of code. Let's try to understand what exactly is telescopic constructor. Then we'll see go through the code part. Does anyone know about telescopic constructor? Come on, guys, quick in the chat. Does anyone know about telescopic constructor? Okay. I see one yes. Nobody else? Okay. If you may or may not know about, I'm pretty sure you might have seen this code in reference. Just try to let me know if you have actually seen this or not. But I'm pretty sure you would have seen at least in one of the code bases. Telescopic constructor is one constructor calling itself inside it. One constructor calling itself inside it. Understand this. Let's say C1 is constructor 1, C2 is constructor 2, C3 is constructor 3. This is what we have. If I create C2, in the implementation of C2, I will do it on top of C1. If I do implementation of C2, I will do it on top of C1. If I have to do implementation of C3, I will do it on top of C2. Okay. This is what you call as telescopic constructor. So C3 is technically implemented on top of C2. C2 is technically implemented on top of C1. So there is a telescope. The purpose of telescope is it has multiple layers, right? So one layer is looking through other layer and so is looking through other layer. This is called telescopic or chain constructors. So sometimes you hear the word constructor chaining or chain constructor. Both are same. Telescopic constructor, constructor chaining, chain constructor. They are referring to just one part, which is this. Okay. What does that mean by utilizing or reusing it? Let me add something here. Constructor chaining. Same thing. Now, to the node part, imagine C1 is initializing 5 parameters. C1 is initializing 5 parameters. C2 needs to initialize 6 parameters. Okay. Out of these 6 parameters, 5 are same as C1. Okay. So C2 wants to initialize 6 parameters, 5 of them are same as C1. So instead of passing all 6 parameters, I will pass only one extra parameter. That's what I'm gonna do. And reuse the C1 constructor for initializing the first 5 parameters. Okay. The only advantage it is doing is reducing the lines of code, nothing in terms of functionality altogether. Okay. So what is happening here? First, let's understand what is telescopic constructor slash constructor chaining. Then we'll see with the code example. Telescopic constructor says, if you have to call a constructor which has new fields and another constructor is taking care of the previous field, why do you want to initialize all of them in the new constructor? You can just call the previous constructor, let it initialize the previous field, which is already happening. In your new constructor, you just initialize with the field which has not been initialized so far. Okay. So your C2 will be built on top of C3 or C1. C3 will be built on top of C2. So this is how constructors are changed together. That's all what it is doing as part of constructor. So if you look at this example, I have this constructor, let's say protocol and protocol comma hostname. Do I need to again set the value of protocol here if this constructor is also setting protocol? Think about it. Think it in terms of just functions. Think in terms of just functions. We're just calling a function, anyways, constructor is just a function, right? So if this constructor slash function is already doing the same job, why do I need to redo this? Instead of that, I can just call this constructor inside it. Let's say I call it this dot URL equal to URL or however I want to call it. If I call this, I don't need this line. Yes or no? I'll pass the protocol value here. If I do this, I don't need this line. All agree yes or no? Because this function is also doing the exact same job. I was trying to initialize this protocol here, but if I call this constructor, that will also do the same job. It will initialize the protocol. All agree yes or no? Come on guys, quick in the chat. This is exactly what constructor chaining slash telescopic constructors are. So we are doing the same thing. It's just that instead of initializing everything inside one constructor or the new constructor, we are reusing the previous constructor to do the same. We are anyways creating more constructors. It's not like we are handling everything in one constructor, but it's just that when I create a new constructor, rather than assigning all the values, for example, if you look at this part, I don't need to initialize 6 values. I can initialize just one value and keep the 5 previous with this guy, right? So I don't need to, my number of constructors is not getting reduced for sure, but inside a constructor, the number of initialization that I'm doing, that is definitely getting reduced. So I will not create 6 fields here. I will just use the one field, which is new. I'll use this for the past 5 fields. And this will use the past 4, this will use the past 3, this will use the past 2, and so on and so forth. Okay. That is something which you call as the telescopic constructor. Now let's go through the code of URL with telescopic constructor. So we have the right baseline to compare with. We'll go here. This was based upon a plain old Java object. Now let's talk about based upon a constructor. Telescopic constructor. This way we have already created constructor protocol and host name already. We have not created constructor for only protocol as they're all strings. That's what we are discussing. Let's see. We have created constructor protocol, host name already, protocol and host as they are strings. No, we still take care of it. Let's go through the code. Then let me know is any specific questions that you have. Now understand what I'm doing in this code, and this is important. Same five fields: protocol, hostname, port, path parameter, query parameter. What I'm doing is, this is URL telescopic. That's the name of the class I've given. I'm passing string protocol. So protocol, I'm assigning it here. Okay, easy constructor, only field one field. Observe this line. This line is important, line number 15. In line number 15, what am I saying? URL telescopic contains two parameters, protocol and hostname. Whenever I get a host name, I assign the host name. But when I get protocol, instead of writing this dot protocol equal to protocol, I'm calling this function. Can you guys see if I highlight this, it's pointing to this URL telescope? Just observe this again in case you have not. I'll highlight this, and just observe it will highlight this part. Okay. Can you see this now? Come on guys, quick in the chat. So if I go to implementation, it's taking me back there. Or if I do right click, and then I go to implementation, again, it's taking me to the same part. What exactly this is doing? This is just telling me, find me a constructor which is taking protocol as an object or protocol as a parameter. This is the constructor which is taking protocol as a parameter. So here, technically I saved one line, but comparing with lines of code is not the right metrics. Technically what I did, I just reused this constructor. My number of constructors are not getting less. I'm still creating 5 constructors. But the purpose here is that constructor which has been created before is now getting reused. Okay. Now go to third part. Here I have protocol, hostname, and port. I am just assigning the port. I'm not assigning protocol and hostname. For that, I'm calling this constructor. If I highlight over this now, it will take me to line number 14. So I have a constructor which initializes protocol and hostname. I don't need to initialize these two separately. Then next, we have protocol, hostname, port, and path parameter. Here, I'm only assigning the path parameter because I have a constructor which will take care of protocol, hostname, and port. So if I highlight over this, I will get this URL telescopic. Okay. Then finally, we talked about protocol, hostname, port, path parameter, query parameter. Again, I'm only initializing query parameter. All other 4 values are taken care by the previous constructor. Correct. We are just reusing the previous constructor. We're reducing some lines of code. So now if I highlight on this is where I'm going for. So technically, it's not doing something different. It's not solving the problem. The problem or the root cause is, if I have to create multiple variations, how would I do that? That is not solved by this. It is telling me how I can create like all these 5 values, but not the multiple combinations part of it. For example, if I want only protocol, only path parameter, and query parameter, can I do that? This approach is not solving that. Same as the plain old Java code, that is not solving that. It is also not solving the problem of creating multiple constructor. Anyways, I have multiple constructors here. The only thing that it has reduced is the lines of code, or it has increased or improvised is the reusability of the code. So I'm now able to use multiple constructors multiple times. That is, I completely agree, but it is not solving the problem that we have for builder design pattern. So we come back here. This is the code for telescopic constructor. Have a look at this code. Any doubts, any questions, any follow-ups, please let me know. So let's quick in the chat. In the meantime, let me add some note here. Number 1, telescopic constructors helps me to reuse other constructors. There is no need to initialize all parameters. Only initialize new parameter. This reduces lines of code and constructor stash initialization calls the previously defined constructor. Okay. However, my issue, my issue still exists. What's the issue? Cherry picked values. Cherry pick slash one moment. Custom parameters. What do you mean by cherry picked custom parameters? If I want to create a URL, let's say with just protocol, host name, and path parameter without any port. If you look at this, protocol, host name, and path parameter. Is there a constructor which is taking care of protocol, host name, and path parameter? No. Protocol is there, host name is there, path parameter is different along with the port. If I don't want this part, if I don't want this part, I only want this, this, and this. How can I do that? One way you can say I can pass this as null or I can pass this as empty and then I can keep the logic. I agree. You can do that. I'm not denying it. But what if I just don't want to pass it? I don't want to modify value as null or empty string or anything. I just want protocol, host name, and path parameter. That's all I want. Okay. So if I want to do that without any port, how will I take care of that? I cannot do it by plain Java code or telescopic constructor. I would need to create a new constructor for that. Okay, but I cannot do it by plain Java code or telescopic constructors. Everybody crystal clear with this? Come on, guys, quick in the chat. Everybody crystal clear with this? Okay. If everybody is crystal clear, now we move to the elephant in the room, which is build a design pattern. Okay. To your question, what are some real life use case of telescopic constructors? So the real life use case of constructor chaining or in general telescopic constructors, reusability of constructor. That's all we use for. Okay. So the whole purpose is, let's say I don't want to initialize whenever, especially in the terms of classes, which has really large number of fields, 20 fields, 30 fields, 50 fields, etc. In that case, telescopic constructor is really useful because you don't have to write the query this dot value equal to another value with 20 or 50 different fields. That's the only use case. Okay. Reusability of multiple constructor overloading. That's what telescopic constructor provides. Okay. Before I go to the builder design pattern code, I just want to revise this problem statement again. Talk about the two solutions we discussed, what is wrong with these two solutions and why we are going to third solution. Okay. I want to revise all of that before we go to the builder design pattern code. First thing, what is the problem statement we are talking about? What is actually we are trying to solve here in terms of code walkthrough? Let's talk about it. The problem statement is I have to create an object called URL. I want to get an object called URL, which contains few essential fields, few optional fields. Let's say protocol and host name are essential and port, path parameter, query parameter, these are optional. This is very much analogous to what we have discussed in terms of a real life example we talked about, a house. There's some essential parts in a house, there's some optional parts in a house. Same thing, right? Now, what are we trying to do here one by one? The first thing that we thought of implementation was by using a plain Java code. Don't use any design pattern, don't use anything, just use a simple plain Java code as a single file and see what it can be done. If you try to do that with that way, you will be technically creating a URL class which contains 5 parameters. 5 parameters will lead to 5 getters and 5 getters will lead to 5 setters, so on and so forth. Okay. So you can do an implementation class. There's a public class URL. You got the 5 values. You got 5 parameters for passing it and for getters and setters. Now what you'll be doing, considering there are 5 different fields, you'll be writing 5 different constructors. Okay. So if I just need a protocol, I'll be initializing this protocol and hostname initializing this and so on and so forth. So you got 5 different constructors. This is what you call as constructor overloading. This will do the job. This will get you the output. We have seen the output. The code was working. This is working fine. But is this a good code though? This is not a good code. Why? If there were 50 fields, you would have created, or you would have ended up created 50 different constructors. That is not something you call as a good code. All the possibilities with constructor would be overloaded. So we'll call it as constructor overloading. This exploits the open close principle. If a new field needs to be added, this will require another constructor overloading. If a new field needs to be added, this will require another constructor overloading. Okay. So this is not a good code approach. Okay. Fine. We talked about another solution. Let's talk about this. Second solution we talked about was telescopic constructor. And obviously that has some problems as well. That is why we are talking about builder design pattern. Telescopic constructor, first of all, it is not completely solving the problem. It is definitely an optimization, no issues about it. It's an optimization than the plain Java code, but it is not solving the problem exactly. It is definitely reducing some lines of code, but the main problem, which is cherry picked values, that is still not resolved. So let's see, understand what this telescopic constructor slash constructor chaining is doing exactly. So in telescopic constructor, you would have constructor which is built on top of another constructor. Let's say C1 is constructor 1 and then have C2 which is constructor 2 which is built on top of C1 and then have C3 which is built on top of C2. So this is how the structure will look like. C3 built on top of C2, C2 built on top of C1, which is telescopic slash chain constructors. Now understand the problem here. Imagine my C1 or constructor 1 is initializing 5 parameters. C2 need to initialize 6 parameters, 5 of them which are same as the C1. So rather than writing the code like this, which I am writing here, this dot value equal to this and this dot value equal to this for 6 times, what exactly I'll be doing is, I will reuse the C1 for initializing the first 5 parameters and I will only pass one extra parameter. Okay, this will definitely reduce my lines of code. So if you look at the code part here, this is class URL telescopic. I still have the same number of constructors. Let's be clear with that. It does not reduce the number of constructor. However, it increases the reusability of a constructor, so I don't need to initialize all the values that I'm doing in all the constructor. So let's take an example of this. If I have to set protocol hostname and port, I can just use the part for port. And I will reuse the part where it is setting for protocol and hostname and so on and so forth. So this is built on top of this. This is built on top of this. This built on top of this. Let me make annotation to make it easier. This is built on top of this. 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 That is what you call as constructor, telescopic constructor or constructor chaining. This part crystal clear to all? Come on, guys, pick in the chat. This part crystal clear to all? Okay. Now, again, this helps me to reduce the other constructors. No need to initialize all parameters. I can initialize the new parameters. It reduces lines of code, right? And for constructor initialization and calls the previously defined constructor. But the main issue of cherry picked or custom parameters is still not solved. If I want to create with some cherry picked values, I don't want to take them in order. Do I still need to create a new constructor? Every time I need to create a new constructor, that's what I have to do with these two approaches. That is the main problem we are trying to solve. And for that rescue, we will have builder design pattern. So let's try to understand what is builder design pattern doing separately, and then we'll talk about one by one. Okay. Let's go back to our IntelliJ. Let's try to understand builder design pattern. Then I'll uncomment a few things here. First, let me comment this guy. We can keep this one commented as of now. I'll uncomment it whenever we need it. Okay. All right. So let's understand the driver code first. Then I'll run the code. Then we'll see the output. What are we doing in the driver code? In the driver code, now I'm going to build an object with builder design pattern. Builder design pattern in the sense, let's import this class too. Builder design pattern in the sense, there's a protocol, there's a host name, there's a port. Okay. So I create this object URL builder. This is from a different class, URL builder class. I created this as URL builder. I am saying builder dot protocol dot hostname dot port. That's it. And what I'm saying, builder dot build. You can pass this as one line also, like builder dot protocol dot hostname dot port dot build. You can write it like this also. Both are same thing. That's it. That's what I need to do. If I did this, now if I want this URL builder dot protocol, I want to print the host name, I want to print the port, it will work significantly. Okay, smoothlessly it will work. Let's see, run the code and see the output. Okay, now if I go with the builder design pattern, protocol, hostname, and port, I'm still able to get the output. I got the protocol, I got the hostname, I got the port. Now understand the beauty of this part. Why are we talking about builder design pattern in the first place? Here I choose protocol, hostname, and port as cherry pick values. Out of these, one moment, guys, out of these five values or out of these five fields, I can pick any of the value. I don't need to go in order. I don't need to go about, okay, first I created protocol, then I created this, then I that. No, I can pick any five values or all the values or in general one value, and I can go in any order. Take second example. I'll comment this. I'll go to this example. What I'm doing here is I'm trying to create again a builder design pattern with protocol, hostname, and path parameter. So the first one was protocol, hostname, and port. We are creating two different variations of object. First with protocol, hostname, and port. Second with protocol, hostname, and path parameter. Now what I'm doing, same thing I'm doing here. I'm creating a builder object. In that builder object, I'm setting the values, hostname and path parameter. I make it build. And here I'm printing the values here. Let's run the code. Let's see the output. Okay. Now it is running. It is giving me the output here. So look at this. This was the object containing combination of protocol, hostname, and port. This was the object which was containing combination of protocol, hostname, and path parameter. I can customize it. I can choose the cherry pick values, the values that I want in my object, and I can generate that object. This part crystal clear to all. Look in the chat, guys. This part crystal clear to all. That's exactly what a builder design pattern is doing, nothing else. Okay. Now the question becomes how it is able to do that. How exactly it is doing that? For that, let's go to the code of URL builder. Okay. This is the implementation part. So what do I have? I have this public static class called builder. In that builder, what I'm doing, I have these five fields: protocol, hostname, port, path parameter, query parameter. Now what I'm defining here, I'm defining the values. When you set the protocol, this is how you set the protocol. Hostname, this is equivalent to the setters there. Okay. You set the hostname, you set the port, you set the path parameter, you set the query parameter. Now, inside that, what I'm doing, inside that, I'm creating a build method, which is returning new URL builder. Okay. And what I'm defining in this new URL builder, look at this constructor that I'm defining. In this constructor, the only thing that I'm defining is I'm passing that builder object. I'm not passing the five fields. I'm passing the entire builder object. And I'm setting those values. I can set the protocol I want. I can set the hostname I want, path parameter I want, port I want, and query parameter I want. You can cherry pick those values and it will still work. And that's exactly what builder design pattern is. Okay. So this was a URL builder class. You start from here. And finally, you define your constructor, which is private URL builder. What do you pass? Instead of passing the five values, you're passing a builder object. This is the key part. You're passing a builder object. So you're setting up the builder object, you're creating the builder object here. So you can pick with any number of values that you want. You can cherry pick and you can get the answer. Okay. In your constructor, when you say builder.build, that builder.build is actually just returning instance of this builder object. So it has nothing to do with what you are doing in terms of your values or what order you're passing. It is everything to do in terms of your builder, this object that you have created. That's it. This part crystal clear to all. Let me take this piece of code ahead. Come back here. I'll cover in the same example. I'll talk about implementation class. And the driver class. All right, I got the implementation class. I got the class. No, those are two different classes. The inside one is a builder class, which ends here. The outside one is a URL builder class. So my constructor is still in the URL builder class. Okay. You're repeating the properties in outer and inner class. No, both are different classes. This is a builder class and this is, see, understand. My URL builder class, which is my customer facing class. In that case, I'm just having a URL builder object here. Okay. What I'm using internally is I'm creating an internal class called builder. I'm constructing an object of builder. So whatever changes I'm making, I'm not making changes here. That's why you see I marked it as final, 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 final. These are marked as final. These are not marked as final. So changes that I'm doing on the builder object. I'm not doing it on these fields. That's what the whole magic of builder design pattern. Okay. If you just pass 5 parameters here and you make changes here, that will become your plain old Java code, right? So instead of doing that, what we do, no, there's no point of removing the final fields. The point of keeping the final field is I'm not modifying these values. I'm modifying the values given in my builder object. That's it. Okay. All right, guys. Have a look at this code. Have a look at this code. Let me know any doubts, any questions. I'll print the output here as well in the meantime. This is the output we have got so far. Okay. So guys, quick in the chat, go through the code. Let me know any doubts, any questions, something that you want me to explain again. I can talk about it. Yeah. This is the builder class. Using at that builder will create an internal builder class like this. Yes. When you say builder.build, see, when you say builder, you first created an object of this builder class. This class I'm not talking about, internal class. Okay. When you say dot build, this is what you're returning, the instantiation of URL builder class. That's it. Okay. All right, guys. Any more questions? Any more doubts? Quick in the chat. Correct. Correct. Build is returning this. By calling constructor of outer class with static class parameters. Constructor of outer class with static class parameters. No, anyway, these are final, right? You cannot change it. So you're just taking these parameters and you're calling this URL builder object. Okay. Okay. Any more questions? Is it mandatory while creating object to use package path.com any other way? Uh, Technically, yes, because the way, see, the way IntelliJ or any ID will read from your code is understanding the structure of the code. So in terms of structure of the code, how will they identify? They can only identify in one way, which is the which package you have used. So in my case, there are multiple packages, right? If you just have one package, one moment. If you just have one package, it's not an issue. But if you have multiple package, you need to provide that path. If we don't use the build inside, then what will happen? So if we don't build the build inside, it will never call this URL builder. So if you don't call this URL builder, it is not getting this builder object. That's it. The purpose of builder.build is you pass the values that you want to build, and then you create an instance of the URL builder class. That's what you're printing the value. URL builder.protocol, URL builder.hostname, URL builder.path parameter. The dot build is creating an instance of URL builder class. That's it. Come on, guys. Any other questions? Quick in the chats. Any questions? Any doubt? All right. If everything is good, let's move on to next part. How we access to properties with dot, can you explain again? protocol dot hostname. Okay. See, what anything that this builder is doing, let's go through this one part. You get an builder object of class, builder class, right? In this builder class, what we are trying to do here is when you say dot protocol dot hostname dot port, this is what it is happening. In dot protocol dot class, whenever you're calling it, this is just initializing these five values. So, and get your question exactly what you mean by this is the syntax of how we use for builder design pattern, if that's what you're asking. This dot protocol dot hostname or whatever values dot a dot b and dot build, that is the syntax of a builder class. Okay, so that's how we access those values. If you want to see here for IntelliJ, I can show you here if that's what clarifies for you. When you say, let's take an example. When you say dot protocol, if I go to the implementation of this dot protocol, correct, every single method returning the object. And if I go to the implementation, this is where it is referring to. Okay, same you can see two usages. If I go to the two usage, line number 25, dot hostname. Okay, each and every instance of them is returning a builder object. Dot build is returning a URL builder object. Builder, URL builder are two different things. Builder is the internal object we are using. This also return builder, this also return builder, this also return builder. Builder.build returns a URL builder. Okay, we are just concerned about URL builder, which is final class. That's the magic of builder design pattern. All right, coming back to this, here we are. Let's go. All right, we just have looked at the code implementation for builder design pattern. Now what next? Usability. Usability in terms of code. Pretty much you have been using this without even realizing it or not realizing it, but I'm pretty sure you guys would have been using it. Have you guys seen by searching builder in your code base, did you find something relevant? Or if you have not done it, you can do it later. I'm pretty sure you will find something depending upon what project you're working on, but at least something in the entire company repository, something used for builder. Okay. It's one of the very popular design patterns for creating complex object. And I believe every project would require some complex object creation. Of course, there are different ways to implement it, but if you're implementing by builder, it would have been much easier. Even if your company doesn't have that code base, there is something that you have been using so far. How many of you use string builder? How many of you use string builder in Java? Whenever I write this code, what are you doing here exactly? When you say string builder dot build, it's creating an object of string builder. That's it. This is just a builder design pattern. That's why I said, even if you have, you definitely would have used it, you might not even know it. Okay. This is a simple classic example of builder design pattern. If you go to the implementation of string builder, you can see the code as well. Okay. All right. What else? Summary, pros and cons. Let's talk about that. We'll talk about pros first, then we'll go to the cons part. So number one, pros is it's a very good way to create slash handle complex objects. It's definitely a very good way to create or handle complex objects. It provides optimization over plain Java implementation. Number three, it definitely provides optimization over telescopic constructors. Fourth, it's easy to implement. And fifth, this can be refactored into later. What do you mean by refactored into later? Refactor into later in the sense, if you started with, let's say, factory design pattern, you start with some other design pattern, you didn't think about how would you be creating the complex object, or at that moment there were no complex object, right? So you prefer to use a simple factory design pattern or simple singleton pattern. Later you realize you have some complex objects to be created, right? The fields that we talked about, mandatory, optional, and multiple combinations. That is when you can refactor into builder design pattern. So this is one of the design pattern which can be easily refactored into. Because at the beginning of a project, you might not be dealing with complex objects, but as the project phases or as the project grows, you might have some of the complex objects created. Okay, so this can be refactored into later. It is only one con, and that con is you have to think of end-to-end chain. Okay. While you're converting into a builder design pattern, while you're making builder design pattern, you need to think of end-to-end chain. That's it. Okay. All right. In terms of how project structure looks like, one moment. I'll answer a question. Let me cover this part. If I talk about any enterprise level code, how does object structure look like? Let me provide that. Nowadays, questions are coming with scenario based, and we need to choose which design pattern to use. That's something you have to anyways know, irrespective of this. One moment. That's something that you have to anyways know. What do you mean by anyways know in the sense? Um, every design pattern or most of the design pattern is very specific in the kind of problems they are solving. So whatever important design patterns I'm covering, the first thing I talk about is what is problem, what is solution, right? So as of now, what we discussed about factory design pattern, the purpose was we want to hide the client code. That is why we go for factory. Okay. Singleton, we talked about we want to create one single instance shared across different application module. Builder, the purpose here is that I want to get complex object. So that is anyways you should know which is what is the purpose of all the design pattern, and then you will be able to answer the questions. Okay. To the second question, what is end-to-end chain meaning? See, end-to-end chain meaning is when I'm creating a builder design pattern, I need to think of how do I need to create these objects. Okay. Or what are these end-to-end chains? That's all. What are different parameters? What the class builder needs to be? What does the internal builder need to be? What's the external builder needs to be? Okay. All right. This is enterprise level code. Usually the enterprise level code goes like this. You would have a folder called utilities. Inside that you will have some configs or constants. You will have controller, which will start with, let's say, a client code slash driver code. That is where your actual code will be. Then you will have implementation, and then implementation might be named as, let's say, it can have validator, it can have service. Inside service, you would have the main files, and then you will have the test files. This is most probably the kind of project structure you would have seen it. I'm 99% sure you would have seen a structure like this if you're working with Java. All of you have seen a structure like this. Come on, guys, quick in the chat. Names can be different. I'm not saying they'll always name as controller, always name as implementation. You can name whatever you want. But usually this is how we like to keep the project structure, enterprise level code. Okay. Now coming to the last part, understanding the applications of builder design pattern. So what is the application of builder design pattern? Let's talk about it. Number one, we can use the builder design pattern to get rid of telescopic constructors. Let's say my program contains telescopic constructor. I want to get rid. How will I get rid? I'll use the builder design pattern. Example, if you have 10 constructors or 10 parameters, let's say, if you have constructor with 10 parameters, calling it will be very inconvenient. Okay. We talked about the example of pizza class. Let's take this guy. would become easier. Take this part. This part you are referring to. Okay. So I don't need to do this multiple constructor overloading slash constructor overloading. I don't need to. What I will do is rather than creating multiple constructor overloading, my builder design will take care of it. Builder design pattern, let's save. Build complex objects step by step. Okay. Instead of dozen of parameters in your constructor. Okay. So my builder design pattern will let me build complex objects step by step instead of dozens of parameters in my constructor. Okay. Number one. Number two, I can use the builder design pattern where we want to create different representation slash variation of same product. Example, build house with windows, etc. etc. Whatever combination I want. I can cherry pick the values. Based upon cherry picking those values, I can create a part of that builder design pattern. Okay. All right, guys. We covered builder design pattern in detail. I'll quickly revise what we covered so far before I move to the next design pattern. I'll just put the heading here. The next design pattern is abstract factory pattern, which is technically built on top of factory. So we'll talk about that in detail. But before we go there, let's quickly revise what we discussed as part of our builder design pattern. Okay. Majority of the things we have already discussed till the last class. We have started with the code walkthrough, understanding what is the root cause and how do we fix the builder design pattern. The problem statement we talked about, we want to create an object of URL. We talked about there are some essential fields, there are some optional fields, etc. etc. Okay. And then we use that, compare that URL analogy with the house. House contains some essential objects and optional objects. Then finally, we talked about code walkthrough. What I would discuss as part of code walkthrough. Number one, if I have to implement this without any design pattern with simple plain code or plain Java code, how would I implement that? If you're implementing with plain Java code, this is what you would have implemented. 5 parameters, 5 getters, 5 setters, all the possible constructors you could have think of. So I got my 5 parameters, I would have 5 getters, I would have 5 setters, and I will try to write as many constructors as you can just to compare all the possibilities. Okay. Then we talked about the driver class. What exactly are we doing in driver class? So in driver class, what we will be doing is we'll be creating an object of this URL object. We'll be setting those values and we'll be putting those values. Of course, it's not a good code because all your possible constructors have been overloaded, which exploit technically the principle of OCP as part of solid principles. Okay. Then what else? We talked about the second solution. Second solution is telescopic constructor, which again does not completely solve the root problem. It's optimization than plain Java code. It reduces some lines of code, but again, it's not solving what we need for. So telescopic constructor slash constructor chaining, what does that do? It will create constructor C1, C2, C3. Let's say C2 is built on top of C1, C3 is built on top of C2, so on and so forth. Means I am not writing a new constructor altogether. I'm reusing the previous constructor. For example, if has 6 parameters, 5 has been used in C1. Rather than initializing all 6 parameters in C2, I will take the 5 from the C1 or just call the C1 and initialize the 6 parameter here. Okay. This significantly reduces my lines of code. Then you finally look at the code part here. We got this multiple constructors here. All I'm doing is every constructor I'm reusing it, right? Why I'm reusing it? Because I don't want to initialize all these values again and again. That's it. Finally, we talked about this is the problem still exists for cherry picked values or custom values. And finally, move to the actual solution, which is the correct solution, which is builder design pattern. What is builder design pattern responsible for? Builder design pattern is responsible for whatever fields value that you have created, let's say 6 in this use case. We'll create a builder object, and that builder object will take care of the cherry picking of values. So verified with multiple test cases, we get the correct output. We talked about usability. It is used in the string builder class as well. We talked about pros and cons. What are the pros? What are the cons? Finally, we talked about the application first to get rid of the telescopic constructor overloading in general. And second, we can create different representations slash variation here. Okay. Everybody crystal clear with builder design pattern. Someone guys quick in the chat. Everybody crystal clear with builder design pattern. So we'll start with abstract factory pattern now. Okay. If all good, let's start with abstract factory pattern. We have around close to 20 minutes. Let's see how much we can cover real quick. This is the last design pattern that we're discussing. After that, we'll move to the case study. So I doubt in 20 minutes we'll be able to complete, but anyways, we should be able to complete in, let's say, 45 minutes or something. And then we'll go to the use cases, our class case studies for 3 parts. We'll talk about a couple of things here. Number one, we'll talk about the problem solved by this. Number two, as always, we'll talk about real life example. Number three, I'll take 2 examples here, just writing for myself. One moment. Warehouse and college using GRE. Facade is not something we're covering, not that important. I mean, it is important, but not covering as part of this. If you have any question related to facade, let me know. I can answer that. Implementation. What else? We'll talk about usability. Then we'll go to the code walkthrough. And finally, we'll talk about the summary, which is pros and cons. That's something we'll cover as part of our abstract factory pattern. Okay. First, let's start with the definition. Then we'll talk about what's the problem it is solving, what's the real life example, so on and so forth. Definition. What exactly is an abstract factory pattern? Now remember, this is abstract factory. So it is factory of factory pattern. Okay. Repeating, this is abstract factory. So this is factory of factory pattern. Means it's a pattern inside a pattern. What is pattern inside a pattern? Let's try to understand why do we have a pattern inside a pattern in the first place. It's a creational design pattern, first of all, means we are going to create objects which belong to a family of similar objects. Number one, what's abstract factory pattern? This is a factory of design pattern or factory of factory patterns. There is a pattern inside a pattern. What do you mean a pattern inside a pattern? We are going to create objects which belong to a family of similar objects. This is implemented using a common interface. Implement using a common interface means implementation is deferred to concrete classes. Just like we have in the terms of a factory, there would be something similar in abstract factory, just on a higher scale. That is number one definition. Number two, explanation. When we say it's a creational, there are a few things that we should know about. This will be used for creating objects of similar type. This part is important. This will be used for creating objects of similar type. That's number one. Number two, it will hide the complexity of object creation. and my client code has no idea about the object creation. Okay, let's go step by step. First, it creates object of similar type. It hides the complexity of object creation. My client code will have no idea about what kind of object being created. So before you have a client code getting access to server class. Same thing that we discussed in terms of factory also. There is no layer of abstraction here. No. Here my client knows about server class details. So what did we do as part of factory design pattern? We introduced something called a layer of abstraction. Okay. Same logic. Same logic. I just put something in middle, which we call as factory. And what is that factory? That factory is nothing. That is just an abstraction. That's all we had. This was the case of factory design pattern. Client first initially had the access to server class. Client knows the detail about what server class details are calling. Once we include a factory, now client is unaware of that. When we say abstract factory, what does that mean? Just built on top of factory. Now, when we say abstract factory design pattern, means there is an abstract factory here, which serves as a layer of abstraction. This can lead to multiple factory classes. So let's say there is one factory class and that has its own concrete classes. Concrete slash server class. Same goes for factory 2 as well. Same goes for factory 2 as well. Okay. All right. This is exactly what my abstract factory is responsible for. So number one, we are creating object of same type or similar type. We definitely had the complexity of object creation like any other creation and design pattern. Client code has no idea about the object creation. This is one implementation we did as part of factory design pattern, where if you remember, I gave you the example of creating different type of balls in the factory, right? Client orders a type of a ball based upon the order type. We are setting it to different concrete classes. Client has absolutely no idea about it, how many factories, how many concrete classes are there. Abstract factory design pattern is one level ahead of it. Now we create a layer of abstraction outside the factory. So in the factory design pattern, factory was working as a layer of abstraction. Now I don't want my client to know even about the factory. I want it to know about something called abstract factory. And that abstract factory is the actual layer of abstraction. So client will have no idea about what kind of factories are there and definitely no idea about what kind of concrete classes are there. My client will only and only communicate with abstract factory. Okay, let's write it down. Number one, client knows nothing about server class details. Client only communicates with abstract factory class. What else? Abstract factory class will communicate with respective factory class. And factory class will tell specific concrete classes to do the implementation. So there is another level which is added here. Okay, which will be more clear obviously with a real life example, but just I'm telling there's another level added here. So client would definitely know about anything about server class detail. Client will communicate with abstract factory instead of factory. Abstract factory will communicate with the respective factory, which factory to be called, and then corresponding factory will call the specific concrete classes. Client is unaware there is a factory. Client is definitely unaware there is a concrete class. In factory design pattern, client was unaware there is a concrete class. In abstract factory, client is unaware that there is even a factory between them. Okay, let's try to understand this with a real life example, then we'll come back here. Third one is a real life example. Okay, so in terms of real life example, whatever we've done in terms of factory, I'll take that reference too, so it becomes and saves our time. I think factory today is what, eighth class. Factory we might have discussed in fifth or sixth. Let's see. Did we discuss? No. Let's go to sixth. Okay. Yep, this will contain the flow. All right. This is what we discussed in the case of factory design pattern, right? In case of factory design pattern, the example we talked about, there is a factory of balls, right? That factory contains concrete classes like leather ball, metal ball, tennis ball. Now my client will place an order of 1,000 leather balls. Inside my factory, there are different departments which I call as concrete classes. Leather, tennis, and metal. My client will have no idea about their implementation. Based upon the order type, I'll be deciding which factory to be called. All of you remember this part? Come on, guys. The very first design pattern. All of you remember this? Okay. Now what we're going to do? We're going to use another level of abstraction here. Before even the factory, or there will be multiple factory by the way. Before even those factories, we are going to introduce something called as a new level of abstraction, which we'll call as a warehouse. Okay. So let's start with this. This guy was factory design pattern. Next, I'll call as abstract factory design pattern. Okay. So example of that is, let's say my warehouse for furniture. Okay. Let's have a client who places an order for 1,000 door of sandalwood. 1,000 door of sandalwood. Now inside my warehouse, I have a chair factory. I have a table factory. I have a sofa factory, a door factory, and etc. etc. I have multiple different factories inside my warehouse. Inside my door factory, let's say, I have multiple departments. Department means concrete classes. So if you want to make a door can be made from sandalwood, can be made from metallic wood, can be made from redwood, etc. etc. Depending upon whatever you want to make. Okay. My client has no idea about any of this. These details are completely hidden from the client, as client does not need to know those details. That is the level of abstraction we have. Okay. Let's talk about the flow for this part. I'll move it here, move it here, move it here, move it here. What do we have? In my client, I have abstract factory, Okay. This abstract factory is what I'm calling as warehouse. Okay. Now in that warehouse, let's say there is sandalwood. Based upon this sandalwood that we have decided, we'll talk about decide which factory to call. Okay. Inside my factory, I have multiple different factories. Let's say I have chair factory, table factory, and sofa factory. So I got chair factory, door factory, sofa factory, and finally table factory. I have multiple factories now in a warehouse. Now coming to the concrete classes. Coming to the concrete classes. I would have the concrete classes like redwood or metallic wood or sandalwood. Okay. Now to this part. The first part, which is we made a decision based upon what? Door to call, which factories to call. And here we'll make a decision based upon what? Sandalwood. This will decide which concrete class to call. Which concrete class to call. Okay. All right. Now let's try to understand this one by one. What are we doing here? We already know about the factory design pattern. What does abstract factory have done? Abstract factory has created one more layer of abstraction, right? Example to understand that in terms of factory, we talked about this factory. There was first concrete classes. So we introduced a layer of abstraction called factory. Now client will communicate with factory and factory will tell the specific concrete classes. Same thing would happen, but now there would be one more abstraction, which we call as warehouse. Okay. So what will happen now? There's a warehouse for furniture. Client places an order of 1,000 or order of 1,000 door of sandalwood. Now inside my warehouse, I have multiple factories. I have chair, door, sofa, table. Inside my factory, I have multiple implementation classes or concrete classes like redwood, metallic wood, sandalwood, etc. Right? Now, in terms of my warehouse, what I'm going to do is once I decide I'm going to want a door factory, now the door can be of multiple types. It can be a sandalwood door, it can be a metallic wood, it can be a redwood. All of these details, client has absolutely no idea about it. Client just know that it has placed the order of a door, 1,000 doors, which are made of sandalwood. Correct? So how it internally works, it has a warehouse. Warehouse has different factories. Different factories have different concrete classes. But obviously, client is not exposed to that. Okay. So depending upon the order type, right? Or depending upon technically order request, I will decide what my abstract factory will decide to call which factory class. And depending upon order type request, my factory class will decide upon my concrete class. And that's it. Okay. So how does my workflow look like? My workflow look like this. My client will makes a call to warehouse for 1,000 doors of sandalwood. My client is not aware of any factory classes or concrete classes. Third, warehouse, the door factory has order equal to door, and door factory would be a sandalwood, has order type is equal to sandalwood, which is a concrete class. That's it. Okay. This part crystal clear to all guys. Quick in the chat. This part crystal clear to all. There's another real life example which I wouldn't have time to cover it, but we'll discuss that as a real life example too. Okay. Let's quickly revise what we have discussed as part of today's session. At least that we have completed builder and abstract factory. We have talked about the theory so far. Now, I'll keep this as work in progress because we have not completed. And then we'll start with case studies. So three more classes, maybe 3.5 more classes. One moment. I'm repeating everything. Three more classes, 3.5 more classes. Your course will be completed for low level design. So first thing first, we start with the code walkthrough for URL builder. We try to make an analogy with the house part. We have done the code walkthrough. We talked about first the issue if I created with a plain Java object. Yes, three case studies will be covered. So 3.5 class, that's what I'm saying. So plain old Java object, what will be the implementation? In that plain implementation, what exactly we are doing, that will not work for our use case. Why? It's not good code. We are creating all possible constructor overloading. If you want to create any new field, you would have to do a separate constructor for that. Okay, not a good practice to do it. Second solution, we talked about telescopic constructor. First, we understood what a telescopic constructor or chaining, constructor chaining in general. We definitely reduce lines of code for sure, but eventually it's not solving the problem that we want to solve. Yes, we focus more on reusability of code, which is great. We are still doing constructor overloading. We are not reducing the number of constructors, but the main problem remains the same. Okay, cherry picking is still not possible. And of course, I have same number of constructors. Then I finally moved to the builder design pattern, which is the implementation part. We looked at the implementation, we verified with different cases, it's working fine. Finally, we talked about usability, which is actually used in String Builder class and many of the classes that you have been using. A simple code search using builder would help you identify the builder design pattern. We talked about pros and cons of the builder design pattern as well. Finally, move to the applications. So I can use the builder design pattern to first get rid of telescopic constructor or constructor overloading. Okay, this is one part. Second, where we can create a different variation of the same product, that's exactly where we use the builder design pattern or the complex objects. Finally, move to the last part, which is abstract factory pattern. Problem solved. Technically, we have discussed this. Real life example, I have covered one example, other is still in progress. So I'll mark it as VIP. And then we'll talk about implementation, usability, code walkthrough, and summary. What is the definition altogether of abstract factory? It's a factory inside a factory or a pattern inside a pattern. So we're trying to create objects which belong to a family of similar objects. This implemented using a common interface and it is deferred to the concrete classes. Since it's a creational design pattern, so obviously client should not have any idea about the object creation. So we building on top of what we have already discussed. So build factory based upon simple implementation of client and server by introducing a layer of abstraction. Abstract factory, I'm having another layer of abstraction. So client code will talk to abstract factory that will internally call to multiple factories and that factory will decide which concrete class to call. So client knows nothing about server class details. Client only communicates with abstract factory. Abstract factory communicate with respective factory. Respective factory will communicate with the concrete classes. That's it. Okay. We talked about the design pattern with an example to understand. For example, if I have a warehouse, in that warehouse, if I want to call for, let's say, door. Now, door will have a separate factory. Inside the door, whatever kind of door you want, that will be a separate implementation class. Client have no idea about what kind of implementation class, what kind of factories exist. Client only knows about the abstract factory. Okay, extra layer of abstraction. This is the workflow part we talked about. Clients make a call to warehouse. Client is not aware of factory class or concrete classes. Warehouse will call the door factory and door factory will call the specific sandalwood concrete class. Everybody crystal clear with whatever we discussed as part of today's session. Come on, guys, quick in the chat. Any doubts, any questions, any follow-ups? Last workflow is this. Client will make a call to one moment. Client will make a call to warehouse. It will say, I want a door, right, of sandalwood. Now from the warehouse, it will check, I want to make a door. Let me call my door factory. So door factory will be called. Other factories will not be called. Now from door factory, it will check what is the type of material you want to make. It says the type of material is sandalwood. So door factory will decide I need to call sandalwood factory. So client has no idea about what factories are there, what concrete classes are there. Client has absolutely no idea. Client is just calling this warehouse. That is the end-to-end flow I've listed here. Okay. All right, guys. Any more questions? Yes, that's what I'm saying. Whether the order is of door or the order is of table or chair or sofa, that is what I'm calling order equal to door. So if the order is based upon door, that is when you make the factory call for door factory. And if the type of order is based upon sandalwood, then you're calling those specific concrete class. Okay. Come on, guys, quick in the chat. All right. Cool, guys. If everything is good, let's wrap up the session here for today. Let's catch up in the next session. We'll resume with our abstract factory design pattern. The code part is pending. And once we complete that, then we'll move to our case studies, three case studies that we have to complete. Okay. All right, guys, let's wrap up the session here for today. Let's catch up in the next session and we'll resume from there. Thanks for joining in and have a good day.